Troubleshooting the 550 catalytic bead system should be quick and easily performed in the field. Although if you're having difficulty with a specific location, it might be simpler to just have replacement components that you can swap out. An alternate instructional tool to this video is located in the 550 Operation Manual, Chapter 5, called Troubleshooting and Repair. Start by unscrewing the domed window explosion-proof housing cover, making sure that you declassify the area if you're working in a Class 1 hazardous location. Once opened, remove the SafeCAL by simply pulling the 5-pin connector off the transmitter located at the bottom of the housing. You will need any standard DVM capable of reading ohms, milliamps, and voltage. Place the meter on the milliamp scale and connect the black probe to pin 5 of the 5-pin transmitter header and the red probe to pin 4. If the sensor is mechanically okay and the transmitter is working, the meter should display a milliamp output between 1 and 7 milliamps, although we would typically expect to see the value between 2 and 5 milliamps. Now you can snap on the sensor gas connector and supply a 50% LEL gas in air mixture to the sensor. This will verify if the sensor has enough life left to perform its function. A change in span from its zero reading, in this example 2.24 milliamps, to its span reading is called delta change and should be approximately 3 to 3.5 milliamps on a new sensor to as little as 0.5 milliamps on an aged or poisoned sensor. In this example, our span is approximately 5.14, giving a delta span of about 2.9 milliamps. This is a perfectly good working sensor transmitter assembly. Now we can remove the gas and watch as the gas dissipates out of the element cavity back to its zero reading. The next test that can be performed is the voltage tests. This can actually be performed first if you suspect there might be a power issue, such as a bad power supply or battery backup system. With the DVM on volts, place the probes on the plus and minus terminals of the transmitter. Although we spec out a 24-volt DC power supply, voltages from 20 to 28 volts DC are acceptable. At this time, you can also verify the sensor is operating at approximately the correct voltage by probing the black and red wires of the 4-pin sensor connector. Typical good values are 5.6 to 6.4 volts. The next test that can be performed is a sensor continuity test or ohm check, which will verify if the sensor elements are intact and not broken. For ease of making the connection, you can use a 4-pin header plugged into the sensor connector to give the probe clips an easy place to attach them to. To perform this test, set your DVM to ohms and using the test probes, check between the green and red wires of the sensor for the condition of the active bead, then the green to black wires for the condition of the reference bead. These values are typically between 8 to 12 ohms. The final check is between the green and blue wires for the condition of the coating resistor potentiometer. This value needs to be between 154 and 190 ohms. More information on the coating resistor setting can be found in the instructional video 550-500 or in Chapter 5 of the Operation Manual. A similar bench test instructional video 550-400 is available for viewing if you prefer not to troubleshoot in the field.